All right, third question was about modern physics, and what they give you is they give you this function, this graph, and then they say it's defined as A times F equals B times K, and K is kinetic energy of the electrons. And they ask you, like, what is A, what is B, and what is F0. So this F0, what is this F0? So as we know, this is photoelectric effect graphs. This is the frequency that is provided. This is the frequency of the light, and this is the kinetic energy of the emitted electrons. So if you think about it mathematically, line of like linear line equation is y equals mx plus b. Y represents y, like vertical axis, m is your slope, x is horizontal axis, and b is y-intercept. So if you write this one in terms of that given function, if you try to connect, like make those two similar, your y axis has k. So we need to write k, we need to leave this k alone. Mx is f times m, so f is my x-axis, and that means a is going to be my slope. And that means negative b is going to be here because b needs to go to the other side. Then b is going to be my y-intercept, and a is going to be my slope. So what is the meaning of those two? Like, what is y-intercept on this kinetic energy frequency graph? Slope of this graph is going to be Planck's constant. So a is actually your h. And if you extend that graph, then you're going to see your initial like kinetic energy. That's going to be negative because that is the minimum. We call it like work function, and work function is the minimum energy that you need to emit electron from a surface. And oh, I forget to talk about F0. So F0 is simply a threshold frequency, and this is the minimum frequency that you need to be able to emit electrons from the surface. And in part II, what are they asking for? Explain the physical meaning of the horizontal section of the graph between the origin and F0. So we are talking about this part. So as you can see at the beginning, F0 increases, F changes, frequency changes, but there is no kinetic energy until you reach to F0. So K represents the kinetic energy of the emitted electrons from the surface. Until F0, frequency is increasing, but kinetic energy is 0, which means there is no emitted electron until you reach F0. Because F0 is the threshold frequency, until you reach to that frequency, you're not going to be able to emit any electrons. So that's why at the beginning you have increasing frequency, but there is no kinetic energy because there is no emitted electrons. So we cannot talk about speed of them or energy of them. All right, and the next part, they give you this dashed line graph, which is the exact same graph of in the previous parts. And they tell you a second metal with different properties than the first metal is now used. On the figure below, which is that dashed one, the dashed lines are the same lines shown in the previous graph. Sketch lines on the figure below that could represent the data for the second metal. Explain one difference between the two graphs. So since they just told you different metal, they didn't tell you if it has like higher work function or lower work function, then we can have before that line or after this line, meaning like threshold frequency. And what we know, the slope of those lines is h, which means slope must be constant. So all of those three lines should go in the same direction. The slope must be the same. But if the metal requires less energy to emit electrons, then it's going to be the blue line. If it requires more energy to emit electrons, then it's going to have like higher frequency, means higher energy to be able to emit electrons. So it's going to be further from that dash line. All right, in the next part, they move to a little bit different concept. So now we have an electroscope, and normally those leaves are negatively charged. And then what they say is they are shining a UV light, and then they are seeing that the leaves are getting closer to one another. So for leaves to be close, you need two conditions. One is you're gonna have more protons on the leaves, so that it's going to have less negative effect, so they're gonna get closer. Or you're gonna have less electrons, so you need to lose electrons from the surfaces, so that you are actually going to have less electrons, and then you're going to get close. So UV lights are basically, since they are getting closer, then that means we don't have any like proton in that case. Like there's nothing related to the protons, but what we know from photoelectric effect, if you shine something like a light to a metal, then if it has enough energy, then you can emit electrons from the surface. So if you think about that phenomena, then we can say that UV light has enough energy to emit electrons from the surface, and that means you're going to have less negative charge on the leaves, then that means you're just going to close more. And in the second part, in the next part, instead of using UV lights, they are using green colored light, but they see no effect. And again, from photoelectric effects, to be able to emit electron from a surface, you need to have certain energy. And that certain energy is related with frequency directly, and UV light has a lot more frequency than green color. So that means green color is not going to have enough energy to be able to emit electrons from the surface. So that means there won't be any change on the surface. All right, next, what they say is they're still using the green lights, and they're increasing the intensity. And then they're asking if it's going to change anything. But from photoelectric effect properties, what we know is intensity doesn't really change anything. Well, intensity only changes the number of electrons that you can emit from the surface. So it doesn't change the energy that you have. Energy directly related with the frequency. To be able to increase or decrease your energy, you need to play with the frequency. And frequency is basically the color. So you didn't change the color. You still have the same green light. That means your frequency is the same. Your energy is the same. So you do not going to have enough energy no matter what the intensity is. So no matter what the intensity, you will still have no electrons emitted from the surface, so nothing's going to change. So you're not going to have any difference even with more intensity. All right, the last question. What we have on the question, so we have a large boat like this, and we have some steel bars on that boat, and let's read the question because you need to know the question first. Large boat like one shown above has a mass mb and can displace a maximum volume vb. The boat is floating in a river with water of density rho water and is being loaded with steel beams, each of density rho steel and volume v steel. The boat owner wants to be able to carry as many beams as possible. So he's trying to load as many as those beams. And the question is, what will be the number of beams that you can load on that boat without sinking the boat? Well, since they're asking for the maximum, that means buoyant force is going to have certain number, because buoyant force is depending on the density of the water, displaced volume, since that has a maximum value, and gravity. So this buoyant force part is constant. That is not going to change. All right, when we have the weight of the boat and weight of the steel, then when those two sum, the weight of those two is equal to the buoyant force, then this is basically the critical point. So if you don't exceed that buoyant force, then you're going to be able to balance it. So let's write down everything in terms of given variables, and let's see what we have. So buoyant force is density of the liquids, displaced volume, and this is basically VB times gravity, and that's equal to the weight of the steels, and that is basically number of the steel times mass of the steels times G plus mass of the boat times G. So since you have G everywhere, they're going to cancel out. Then number of steels is going to be equal to density of the water times B, volume of the VB, and subtracting mass of the boats from here. Then we cannot use M steel because that's not given as a variable. Then we need to use that in terms of density and the volume of it. So if you just write this in terms of density and volume, then and replace it in terms of for like M steel, then we're going to be able to solve this mathematically, and your number is going to be basically that equation. All right, next part. Unfortunately, that's a long question, and normally that's like one whole lecture for me to explain to my kids, but they just asked that in one part, and they needed enough explanation. Let's see if we can go through that. So the captain is able to, like, he's seeing some green area. So he sees that oil is leaking from the boat, and then he sees some green area on the water, and then they're asking what's the reason for that. So that's basically thin film interference. So what is happening in thin films? So when you have certain layers, different mediums, then light is going to reflect and refract. And when light is refracting, it doesn't actually change the phase. Phase means the wavelength is not going to shift. All right? But whenever it's reflecting, depending on the surfaces, it might shift the wave. So if you go from low index of refraction to a high index of refraction area, then you are going to shift your wave by like half of the lambda. So if you think that case, if you go from 1 to the reflected ray is going to, it's going from air to oil, so it's going from low index to high index. That means it is going to be shifted. So 2 is basically shifted ray. So 1 to 3, you're just refracting. So when you're refracting, your wavelength is actually changing, but the shape of the wave stays the same. So 3 is going to be in phase with 1, but it's going to be shorter wavelength. But then what's going to happen? It's going to hit the water, and then it's going to reflect. But this time what's happening, it's going from oil to water. And oil has an index of refraction of 1.5 and water has 1.33. So if you're going from high index to low index, when you're reflecting, there is no phase change. So that means 1 and 3 are in phase. So 3 and 4 are in phase as well. And 4 is refracting when it's going from oil to 5. So oil to air. Then 4 and 5 are also in phase. Then what is the result? 1, 3, 4, and 5 are in phase, but 2 is out of phase. So that means 5 and 2 originally, from the reflection and refractions, they are out of phase. So those two rays are destructing each other. So normally, technically, you shouldn't be seeing any color on the surface. However, that length, that distance, is also giving some more distance. So the wavelength of this 5 is actually changing over here a little bit because it is traveling more distance. So if that distance is in a certain distance, that is going to create another phase difference, then that 2 and 5 can interfere constructively. So basically in that case, depending on the thickness of this layer and depending on which reflection rays we are talking about, you can see some region with color, and that is because of that thickness and the way that they are actually interfering. So it's really difficult to explain it without like explaining all of the details, but in a short part I tried my best and I tried like my explanation over here. But to be able to like explain that question perfectly, you need like longer than just 5 minutes. So I'll just skip that. But so 2 and 5 are interfering constructive, and that constructive wave, they have a certain wavelength, and that wavelength corresponds to frequency, and that corresponds to color. So that color is green for that case, and those two waves are basically interfering constructive. Alright, so let's move to the last part. Last part was probably the easiest part of the question. So we are talking about that boat, and it is going from 60 meter width to 30 meters width, and it's the same height, same depth. So that's simply Bernoulli's equation, or volume rate being constant, and volume rate is basically volume over time, and volume can be described as area times length over time, and length over time is velocity. So area, which is width times height for this case, times velocity is going to be constant. That's due to conservation of basically mass. So the width for the first case is 60, and the height we don't know, but it's just height times 5. This is the velocity in that width region. And in the second case, you're going to go with 30 meters width and then the same height, and they're asking for what your speed is. So if you do the math, heights will cancel out and your speed will be 10 meters per second. So that is 2018 AP Physics 2 questions. Hopefully that was helpful, and thank you for listening.